Ugh, that glowing check engine light. There's nothing quite like that feeling, right? It just sinks your stomach. But hey, don't worry, if your Chevy is throwing a P00CA code at you, you are in exactly the right place. So let's dive into this and turn that feeling of stress into a real solution. I'm going to give you a clear step-by-step guide to what this code really means and how you can fix it.
So, if this is what you're seeing on your scanner, let's get right to it. This code is actually pretty specific, and just understanding it is the first big step to getting your car back to running smoothly, and, hopefully, avoiding a costly and maybe even unnecessary trip to the shop. Okay, first things first. Don't think of this code as a disaster. It's not. Think of it more like a message from your car. It's trying to tell you something very, very specific is happening. Our job right now is just to translate that message from all the technical jargon into plain, simple English. Now here is the official, super technical definition. Fuel pressure regulator 1 high control circuit is receiving high voltage. Yeah, I know, that is a mouthful. But put simply, it just means there's an electrical issue with the part that helps manage fuel flow. Stick with me here, we're going to break down what that actually means for you and your car. So the most crucial point is this. Your car's brain, it's called the engine control module, or ECM for short, has noticed an electrical problem. This isn't necessarily some huge catastrophic mechanical failure. It's just seeing a high voltage reading somewhere it shouldn't be. And that right there, that's our main clue. And what's really interesting is that the ECM is pretty smart. It doesn't just throw this code out randomly. Nope, it's a careful observer. The P00CA code only gets triggered when a very specific set of conditions are all met at the exact same time. Let's take a look at what they are. First off, your engine has to be running at more than 600 RPM. All this really means is that the car is on and either idling or actually driving. It can't just be in the accessory position where the radio works. The whole system needs to be active for it to spot the fault. Second condition, the battery voltage has to be above 11 volts. This just makes sure that the ECM has enough juice to run all of its diagnostic checks properly. You know, if the battery was too low, it could get all sorts of weird, false readings, so this condition prevents that from happening. And finally, this high voltage problem in that fuel pressure regulator circuit, it has to be detected for more than 1 solid second. This is important because it tells us it's not just some momentary glitch or a random flicker, it's a persistent problem that the ECM is flagging to get your attention. All right, so now that we know why the code pops up, let's get to the fun part, the diagnosis. We're going to approach this like a detective, okay? And we'll start with the simplest and most common culprits first. Best of all, you can do these initial checks yourself. Your first move is just a simple visual inspection. Take a look at the wiring for the fuel pressure regulator control circuit. You're looking for 3 things. 1, any plugs or connectors that might have come loose. 2, any wires that might be rubbing up against metal, which can cause a short. And 3, look for any obvious breaks or cracks in the wire itself. We call that an open circuit. You'd be surprised how often the fix is as simple as just plugging something back in securely. But what happens if the wiring looks totally perfect? Well, if your visual inspection doesn't turn up any obvious issues, our investigation just moves to the next logical step. We start to consider that a component itself might have failed. Let's talk about how to pinpoint the faulty part. This pretty much lays out our 2 main paths forward. So, as you can see, it's possible that the sensors that measure engine speed or battery voltage are the real issue. They might be sending bad data. It's worth checking them. However, if your wiring checks from the last step didn't solve the problem, then the evidence is pointing pretty directly at one culprit. It's probably time to replace the fuel pressure regulator itself. Now, before you run out and start ordering parts, hold on. I've got one more pro tip for you. This is something the experts always do, and it can save you a ton of time and a massive headache: checking for service bulletins. So, manufacturers like Chevrolet, they often release these bulletins when they find a common problem or maybe a better way to do a repair. A quick online search for Technical Service Bulletins, or TSBs, for this P00CA code on your specific model could reveal a known issue, a shortcut, or even a redesigned part. It is an absolutely invaluable step. So let's recap our action plan. It's simple. Start with a good visual inspection of all the wiring. Look for loose connections, shorts, or breaks. If that doesn't solve it, consider checking the sensors. If those are fine, the fuel pressure regulator is your most likely culprit. And always check for those service bulletins before you finalize your repair. This is your roadmap to getting this fixed. And there you have it. You now know what P00CA means, you know what causes it, and you have the logical steps to diagnose and fix it. That check engine light isn't so intimidating anymore, is it? You have the knowledge and a clear plan. So, are you ready to pop the hood and solve this thing?